Hi everyone. This is Sai from Let's Upgrade. So let's talk about how to get your certificate. It's very simple. You will see two links in the description. Number one is the place where you have to go and mark your attendance. Marking your attendance tells us like, okay, you are a legit student who have attended this particular session. Link number two is your assignment. This is where your 90% of the priority is. You have to go and submit the assignment that is given to you in this particular session. Once you're done submitting that assignment, we will be evaluating that. We will send you an email. If you get the passing criteria, then only we will give you the certificate on a particular date that is mentioned again in the description. Please check these three things, and this is the way how you will get a certificate from Let's Upgrade. Number one, mark your attendance. Number two, just go ahead and upload your assignment. Check for the email that you have received it, yes or no. What is the feedback that you have received from your trainer? Number three, check on which date the certificates will be released. Thank you. Bye. All the best. Happy learning.
Hey everyone, welcome to another interesting workshop where today we're going to talk about an interesting concept in today's domain of generative AI, that is retrieval-augmented generation. So in this workshop, we're going to create our first RAG system, right? So if this sounds interesting, let's look at the contents that we're going to discuss. So in the context, the first thing we're going to discuss is the introduction and overview of RAG, and then what is basically RAG. So we are here to solve the two biggest problems that LLMs today face, right? Hallucinations and lack of proprietary knowledge. And both these limitations can be clearly addressed using retrieval augmented generation. So we are going to see that hands-on in today's workshop. So this is a code-first hands-on workshop focused on building a foundational RAG pipeline. So without wasting further time, let's finish the remaining contents. We're going to discuss the software and components, and then in the remaining 4 bars, which you see here, we're going to be coding different components of the total application. And then at the end, we're going to discuss about how you can basically chunk in text and then play around with the tool. So without wasting further time, let's go to the next section. So let's discuss what is RAG, right? So if we go to the next slide, right, we see that RAG is basically this flow chart that represents the prospect of, adjoining a document to a prompt, right? So what we do in practice is that we give a prompt to a large language model, and then the large language model responds with the appropriate answers. But it's important to understand that this large language model, like maybe it's ChatGPT or Gemini or any language model for that matter, it's been trained on some kind of data until a particular date, right? Like for example, the latest version of GPT has been trained on data until July 2025. So post July 2025, if there's any event occurring, and then you ask the large language model about the occurrences of this event, it might produce an answer, but then the answer is going to be inappropriate, right? It will just try to produce some answer to satisfy your quest, but the answer is not going to be correct one. So this phenomenon is called as hallucination, right? And this hallucination is something which prevents the language model from correctly answering your questions. It produces an impression of a correct answer, but it's not actually a correct answer, right? So that's hallucination. So this happens because it lacks proprietary knowledge. Let's say you have your own medical research firm, or your own law firm, where you have proprietary knowledge, which is specific to your firm, which is not publicly available. So it's obvious that this large language model is not going to be trained on this publicly available data, right? On this private data, right? It's going to be trained only on publicly available data. So how do you go about training this LLM to answer questions on that data set on which it is not trained on? So this can be achieved in two different ways. The first one is fine tuning. So what fine tuning is that you change the trained parameters of the model. Let's say your GPT has been trained on, like, say, billions of parameters. You retrain those parameters, some of those parameters, using your proprietary data set. This process might require like days or weeks or even months, because this requires robust GPUs as well, because that takes a lot of computational power. But then, is it worth it? That's the question. Because if your proprietary data is just a few documents, right, like 2-page document or maybe 3-page document or like 10-page documents, right? Why would you go for fine tuning the entire model when you can have a simpler technique to do that? So that simpler technique is RAG. That's retrieval augmented generation. So what happens here is that the original LLM that you see here, the yellow colored one, that remains untouched. All right. And what we do is that the prompt which we otherwise send to the large language model, right? Like if we ask certain details about this document to the large language model, it's going to hallucinate in the normal course. But then what you do is you feed this document along with the prompt, which creates a contextual prompt. So you save this document somewhere in your vector database or some sort of application therein, and then this prompt learns vector embeddings from this document and creates a contextual prompt, right? So even in your usual prompting, right, we create context to a prompt and then we send that to the large language model. We do that, right? Like say you are an expert in machine learning, can you answer this query for me? We give such context, right? So similar kinds of context are automatically created from this document to the prompt, and then this contextual prompt goes to the large language model, and then that enables the LLM to answer your question in a better way. So the intelligence of the LLM is utilized, right? And your contextual prompt is fed to the LLM. So both these things combined together give you the response that you want. This process is called as RAG, Retrieval-Augmented Generation. And then today's workshop is about this RAG itself. All right. So like long story short, this is an alternative to fine tuning, which is a more arduous process. RAG is an easier process where all you have to do is just embed your document as vector embeddings in some vector database, and then the prompt gets a context from that data, and then your contextual prompt gives you a more specific response from information from your document than a regular prompt, right? So that's RAG for you, right? So in the next section, let's learn about the required software and the components that are required for you to build this workshop, all right? So let's go to the next section. So let's have a look at the software and components. So first thing that you require is a version of Python that is 3.10 or higher, because if you look at the libraries, right, the four libraries that we would require here for this project are, the first one is Google Gen AI, because we're going to implement this RAG using Google Gemini as the large language model. So we require Google Gen AI. Then the user interface is going to be in Streamlit. So we require Streamlit. Then the third one is PyPDF, because we're going to parse a PDF document most probably. So we require PyPDF to read the document and parse it. And then Python docx is another library that basically helps you to parse Word documents. So you require Python -docx as well. So please pip install these four libraries before you get started with the actual coding. So these are the requirements for the workshop. In the next section, let's actually start building your project and start coding the various components, right? So without wasting further time, let's get started. So in this section, we are going to start coding the first component, that's the document reader and the parser, basically that section and those functions that enable the application to consume your documents as chunks of text, which you want to be feeding as the input, where you're going to be asking questions to that portion, and then the RAG tool is going to generate the answers to that content, right? So let's create a new project first. So we go to the directory. I've created one already. So select this folder, and then the name is given as RAG. Right? So let's say create. So here we go. We've created this. So let's save this as rag.py, right? So let's start let's start importing the libraries first. So just maybe add them from my notes here. So import Streamlit, then OS, then some system libraries like OS, and then these are the ones that are usually required. And then we also import these two, like right, the Google Gemini library. So we imported the libraries required, and then now let's start writing the document parser section. So see try, then accept. Right, so this is about the, similarly for the Word document as well, we create another section, right? So now let's define a function called as read document content. Comment to the function. Let's give an argument. So here, basically, you're parsing the file name, basically here, and getting the file extension. Now you're at try accept block. So now we are checking if the file is txt file or .md file, and we're returning the parsed value of that file. Then else the file is a PDF file, then we're checking if it's a PDF reader. Otherwise, we're creating a reader value here. Now what we do is extracting different elements of the text in this loop. Now we have finished the PDF part. Now let's go to the Word document part. Now we're checking if the document is a Word document. So write this piece of code down now. So now we are checking if we have this library installed right in this section. And if it does, then we are saving the value into a variable of the document and creating an object. And then we are parsing, we are basically joining that text down here, and then so we return text. Otherwise, returning an error if its file extension is not a supported format. So if it's not either of these, right, text or MD or PDF or docx, then we're returning an error saying that it's an unsupported format. All right. So we're building a tool that consumes a file extension. And then if there was an error reading the content entirely, and so you see we have this first try block here. We have to support that with an exception. And we say error reading file content. Right. So in this way, we have finished the document parser section. So we import all the document parser libraries here, and then we have created a function that basically reads content from the documents that we feed to the tool, right? So the next section, let's start coding the actual Google Gemini components, the components that call the Gemini API and then go about the Gemini tools, right? So without further delay, let's go to the next section. All right, so let's start coding the Google Gemini components now. So let's first do the configuration. So here, what we do is we get the API key. So you have to set your environment variable called as Google API key and then store the API key for that environment variable, right? And then you can get the API key using this keyword, right? Using get environment. The model that we use is going to be Gemini 2.5 flashlight because that's a faster model for RAG tasks, right? Specify these two components, and then now define a class called as Gemini API. And then we write a whole lot of code therein. We say first define the class, right? And then define the API key. And then before this, we also have to create a conditional input. Or so we can leave that part. Now we can create a new function called as generate content. This is the actual function that called the Gemini API with the RAG content. So and right, so here the streamlit session state. There's something called as a monk state here, but then we don't have to really do this. So like we can just skip this part. And just directly go to the actual API call. So we just say try, then accept, right? So now we initialize the client. We say client equals genai.client. And then we give that a grounding instruction, right, to generate config. So there's a parameter called as system instruction. So we've done that. And then now what we do is call the API using the contents, right? So we say response is client.models.generate content. And we pass the model equals model, then contents equal contents, then the config equals config, right? So now the next thing is to create the RAG. So I think we've defined this fair enough now. Is that so? Let's review what you've written. So we've created a class called a Gemini API where we have initiated the constructor where we pass the API key, and then we have created a generate content function which consumes the contents, right, and the model as arguments and the system instruction, and then we have called the client over here, then we have passed the configuration, and then we are generating the response, right, from this function called as generate content. All right, so we are good to go here. Now in the next part, let's see how we code the Streamlit components, right? So let's code the user interface now using Streamlits. So without wasting further time, here we go. So let's start coding the Streamlit components. So let's add a comment here saying Streamlit UI and logic, right? So first let's meet the config. The title is rack workshop and then the layout is white, right? So we are now defining the user interface. The title is first rack system, contextual Q&A with Gemini. That's the title of the page. Then we create a markdown there. This application demonstrates the core concept of retrieval-augmented generation. Then let's say the LLM Gemini is forced to answer your questions only by referencing the document that you provide. Then we say supported file types are txt, md, .md, .pdf, and .docx. Then the next thing we do is initialize session state for file content and response. So basically, we're just trying to handle certain aspects related to the UI elements in this component here. So next thing what we're doing is we're basically, let's add a comment here, say change the RAG response to a dictionary to store both prompt and the answer. So and then this is basically about the user prompt. Now what you're basically going to do is create the browse button, right? The browse button, which is basically going to be uploading. So you'll be having a button in the user interface, which is going to be enabling a browser box for you to browse to your data source file, right? That file is going to be some PDF file or some Word document or whatever. So there's the browse button, which we are coding now. So the API for that is file uploader, right? It's file uploader. Text which accompanies the file uploader, which is this. Then we say we write a note there that says help upload a document that Gemini must reference to answer your questions. Okay. This is the note which we add to the user therein. And now we check if the file is not blank, right? We check whether the user has actually uploaded something. So if uploaded file is not none, then use the new generalized function to create the content. The file contents equals read document content uploaded file. So this read document content is something which we have created here, right? So this function is now going to be used in Streamlit at the bottom, where we pass the uploaded file and then it reads the entire content from there, right? So now we are handling the issues that might arise with the file content. So like if the file content starts with error, we flag an error. Otherwise, what we do is we get the contents and then we say uploaded file loaded successfully, right? So like once the file upload is successfully done, this is what we populate there. Then now if the user wants to review the content within the file, we have this functionality here called as streamlit.expander, where we review the document content. However, we truncate the content to only 2000 characters, but that's still fine. You can just get an idea of what's the file having within itself, right? We say display text. So now we're displaying the content within the files. If the user has not uploaded the file, it's going to be coming basically here. And we say, please upload a file in the Q&A section. And then we say streamlit.stop, and we stop the process here. Now we start coding the text box. So now we have coded the button, right? If we have coded the button, the browse button, right? Now let's code the text box. So what is this text box? Text box is the one where we enter the prompt, right? That's called as a subheader. So all right, so the next thing we do is we handle the text area, which basically has a label like enter your question here, and then this is just an example. That's not really the actual prompt, but then that's where these are like labels that we have in the text prompts, right? And now we actually have the API handlers here as well. The Gemini API handler. All right. So in this way, we have finished coding the Streamlit component. So now the last part, the final part which remains is basically the RAG query, the main component, right? That function which basically handles the RAG component. So let's do that in the upcoming section. All right. So let's go ahead with that. All right. So let's start coding the RAG components now, which is the final piece of code that we're going to write. So let's define the function. Let's say def run RAG query. Right. Now you're fetching the prompt input in this first step. We say current prompt equals session dot streamlit dot session state dot get user prompt input, right? Suppose that's blank, then we have to handle it. Say if not prompt. Suppose it's blank, then say streamlit dot error. Please enter a question. Right? We say return. Then we check if any document has been uploaded or not. So if document is not been uploaded, which means like if not streamlit dot session or uploaded text, then please upload a document first. Right? So I prompt the user to upload a document, right? And return. And then so RAG response is basically the response generated from the current prompt, right? Now what we do is in the next lines, we basically augment the response for the prompt using this API. So now you're defining the system instruction, like the main prompt here, right? Let's say you are an expert Q&A system. Your sole task is to extract or summarize information to answer the user's question. Do not use external knowledge. Only use the text provided in the context part of the prompt. Right? So the context part, it comes from the document that we upload, right? So if the answer is not present in the document, you must reply with, this is the entire prompt that we give to the. Now we will create the contents payload. So after the system instruction, the next job is to create the contents payload. So we do that in this way. It's a dictionary called as, which has keys as parts, and then another key as parts, which takes the query. And we close the square bracket. And now we call the Gemini API. We ask Gemini to generate content. So the model equals model name, and the contents equals the contents payload. This is the content that we feed the Gemini prompt, right? And then the system instruction equals the system instruction. And then we fetch the answer in Streamlit using this response text, right? So whatever response the Gemini API generates, we feed that to Streamlit in the answer section. And now we have defined this function that runs RAG query. So now we have to create that button in Streamlit, which basically calls this function, right? Which basically utilizes this function. So let's devise that button, say button to trigger the RAG query, say Streamlit.button. We say we label the button as the get grounded answer. So then the output box, it populates a response is the most important one, right? Because that's where your final response is going to be seen to the question. So we create a subheader object, and then we say if streamlit dot special state dot get rag response and streamlit dot session state rag response dot get answer. So now what you want to do is you want to explicitly display the prompt that generated this answer. We say streamlit dot markdown markdown again. What we do is we pass the rag response, say question asked, question asked, streamlit dot session state rag response prompt. Then same thing for answer. Rag response answer. Streamlit dot markdown else streamlit dot info. Let's say your answer will appear here after you click get grounded answer, right? This finishes the, yeah, at the end we need a line that says streamlit dot markdown to close the statement. So let me just give a caption. This is for the user friendliness of the tool. So let me say workshop key take away. The RAG system works by constructing a powerful prompt that includes both the external context, your document, and the user's query, forcing the LLM to act as a document reader, right? So with this, we have finished the generate RAG query function, as well as writing the Streamlit components that basically call this function, right? So now it's time to play around with the tool and see how the tool looks like, and then upload a document to which we will be asking questions, right? So let's do that. All right, so before we play around with the tool, there are some minor corrections, but important corrections to the code which you need to make. The first one is, you see the screen here. You have to, in this function, you need to add return response dot text, right? Because this function is not returning anything. It has to return the response, and then the method is response dot text. Otherwise, it will return a blank content, right? So that's important. And then the second one is you go to the top. You see this PDF reader is not in the correct format, so it should be capital P and capital R. So just copy that and paste it here. Right, so there you go. Now you're good to go. So just save this code, and now let's go to the next section to run the tool. All right, so now it's time to play around with the tool. So this is what all we have covered so far, right? We have covered the introduction and overview, then what is RAG? We discussed that in detail in this slide, and then software and requirements, the libraries required, and then we have coded these four sections, right? So the document reader and parser, then the Google Gemini components, then the Streamlit components, and then the RAG components. And then we made some minor corrections to the code, post which now we have arrived at the final part of this workshop where we want to actually play around with the tool, right? So let's do that. Let's go to the folder where we have this application saved. So we go here, then we copy the path of that application, then we go to the Anaconda prompt. And then allow that to load. Then with the Streamlit, run the application. So now the user interface is going to open. Let's allow it to load. Here we go. So this is the user interface, right? So that's a beautiful title saying first RAG system, contextual Q&A with Gemini. And then this application demonstrates the core concept of RAG, the Retrieval-Augmented Generation. The LLM Gemini is forced to answer your questions based only by referencing the document. And supported file types are text, .md, PDF, and docx, right? So let's upload a PDF document here. The document which I've selected is the following one. As you see, it's the one that I've downloaded on the desktop. I'll just double click on that. So it's basically a paper, a scientific paper published on the topic, a survey of large language models, right? So it talks about the different kinds of large language models that have been used in practice, and as you see here, and then the key characteristics of them, and then how they distinguish themselves from each other or something like that, and then different parameters defining each of them, right? So what we are going to do is we are going to upload this paper as an input document to the RAG application, and then pose questions to the RAG applications to provide answers from this document, right? That's what we're going to do. So let's close this. Now let's say browse files. Then just double click on this. All right, so here you see the message that says a file, survey of large language models.pdf is loaded successfully, right? So now let's click on this functionality which we had coded, right? Review extracted document text, which allows us to view the content within the document. So I click on this. Here you see that the first few paragraphs have been, in fact, the introduction has been loaded here for me. It says truncated for display, but yeah, we had kept a limit of 2,000 characters, right? So it's doing exactly that for us, 2,000 characters, right? So I close this, and now I'm going to ask a question to the RAG, like saying, what is the main theme of the paper? Let's say scientific of this scientific paper. So let's see what it gives. Let's click on like get grounded answer, and then let's wait for the response. All right, so here you go. The question asked is, what is the main theme of the scientific paper? And then the main theme of this paper is a survey of large language models covering their background, key findings, and mainstream techniques. So the paper focuses on the four major aspects: pre-training, adaptation tuning, utilization, and capacity evaluation of LLM. It also summarizes available resources for developing LLMs and discusses future direction. So in this way, we have successfully asked a question to the RAG application, and the application has given us an answer, right, in a summarized format. So in this way, you can just try playing around with the tool with your own sets of questions and get the answers from the RAG. So that's how we have basically fetched the correct response from a RAG application. I hope you have enjoyed this workshop. Stay tuned for more workshops in the future. So I wish you all a very happy time with your studies. And until then, take care and see you in another session. Bye bye.